This is Kannarajan Rajaratnam regarding the project Human Factors in AI Week 4 project. The designing a user interface. My project is designing user interface for the ORAN network, that is predictive maintenance of network equipment. How to prevent using the user interface. It plays a crucial role in enabling network operators and maintains teams to effectively monitor, analyze, and respond to predictive maintenance, alert, and insights. What is the task analysis? For the design, the user interface of predictive maintenance system facilitates seamless interaction between users and the machine learning model, AI machine learning model, empowering network operators and maintains teams to make informed decisions, to take maintenance action, optimize the network performance. The user interface serves as a critical tool for visualizing and interpreting to maintain the network. It's an AI-driven system. The key task associated. First thing, the dashboard design. Create an intuitive and visually appealing dashboard that include real-time data visualization, implement equipment status indicators, and key performance metrics. Second, in the alert notification, that is very important. To get alert, then we can get into the problem and solve the problem as soon as possible to avoid outage. Root cause analysis support. Incorporate tools and visualization that aid users to conducting root cause analysis to avoid later issues. Visualization. Develop interactive charts and graphs that visualize anomalies detected by the machine learning model. Maintenance schedule. Performance evaluation metrics. Display performance evaluation metrics for the predictive maintenance model, such as accuracy, precision, recall. Visually understandable format. Second, the third, what is the based on task analysis? There are several insights on how to simplify the task flow and improve the user's experience. Dashboard design, clear performance evaluation metrics, interactive anomaly visualization, notification, responsive design and accessibility, user-centric equipment details, user feedback. Dashboard design that is visually appealing and user-friendly dashboard that presents critical information at glance. Displays performance evaluation metrics in a clear and understandable format, provide context and explanation for each metric to help users to interpret the model performance accurately. Create interactive and easy interrupt charts and graphs for anomaly visualization. Simply set the alert notification system by providing clear and concise alerts that include relevant information. Ensure that the equipment details interface is organized logically and presents relevant information in the user-friendly manner. Ensure the user UI is responsive, adaptive, and accessible across various devices and screen sizes to enable users to access critical information from anywhere, even the mobile device. User feedback. Implement an easy-to-use feedback is very important, mechanism that encourages users to report false positives and provide suggestions for improving the system performance. Next, what is the user experience design? The proposed solution for user experience design is the predictive maintenance of network equipment in ORAN will involve an interactive and user-centric interface that empowers network operators and maintenance teams to efficiently monitor, analyze, and respond to predictive maintenance insights. Dashboard overview will provide the users to present with an intuitive dashboard that provides a comprehensive overview of the network equipment's health status. Anomaly visualization can navigate to the anomaly visualization section to access interactive charts and graphs that display detective anomalies in the network equipment. In equipment detail, users can access information about individual network equipment through a user-friendly interface. Maintenance requirements. Maintenance scheduling interface will enable users to plan and manage maintenance activities based on predictive maintenance, alert, and prioritization. What are the key considerations of a product user experience, product UI experience design? First, user input, any feedback loops. User-centric design, prioritizing understanding the needs and preferences of the end user. Through user research, gather insight into the specific inputs user would like to provide and their performance for interacting with a product. Easy and intuitive input mechanism. Design a simple and intuitive interface for users to input data or queries. Feedback mechanism. Incorporate feedback loops to allow users to provide feedback on the AI performance or suggestion for improvement. Error handling and validation. Implement clear error message and data validation to guide users in providing correct and relevant inputs. What is the transparency on the model? Explainability. Ensure that the AI model prediction or decisions are explainable and transparent. Users should be able to understand how the AI arrives at its conclusion. Model insight. Provide users with insight into the key factors influencing the AI decision, highlighting important features or data points that contribute to the output. Visualization and summary. Use interactive visualization and summary explanation to illustrate the model's working in a user-friendly manner. Model performance metrics. Users can access information on the model performance, accuracy, precision, recall, and for. Ethical consideration. Communicate any ethical consideration associated with the AI product, such as data bias. Explain measures taken to address them. What is the communication uncertainty? Confidence scores. Provide confidence scores or probability with AI prediction. Use uncertainty warning in case where the AI model is uncertain or lack of sufficient data. We clearly communicate to users visual clues, visual cues. Use visual cues such as color coded indicators or progress bars to represent uncertainty levels, making it easy for users to understand. Contextual explanation. Explain the reasons for uncertainty and potential sources of variability to provide users with comprehensive understanding. Privacy consideration. The data must address various privacy related concerns to ensure ethical and responsible use of information. What are those privacy considerations? Data collection and storage, data security, data minimization, anonymization, data sharing and third-party access, data retention and deletion, sensitive data handling. Data security, what is? AI system must implement robust security measures to prevent unauthorized access, data breaches, and potential cyber attacks. AI system should adopt the principle of data minimization, collecting only the necessary data for the intended purpose. Reducing the amount of personal data collected helps mitigate potential privacy risk. Informed consent. Obtaining informed consent from user before collecting and using their data is critical. Anomalization. When possible, AI system should use techniques like anomalization to identify personal data, reducing the risk of re-identification. Data sharing and third-party access. If data is shared with third-party partners or services, AI system must have clear data sharing arrangement in place to protect user privacy and ensures responsible data handling. Data retention and deletion. AI system should have policies in place for data retention and deletion. Sensitive data handling, user rights and sensitive data handling, user rights and transparency, and fairness and bias for other privacy consideration we need to consider. The privacy laws applicable to the AI product, what are those? The privacy acts mainly, first thing, California Consumer Privacy Act, Personal Information Protection and Electronic Documents Act, Health Insurance Portability and Accountability Act, Data Protection Act. First, the privacy laws applicable to the AI product for product maintenance of network equipment may vary depending on the geographical location of its deployment, and the data is collected and processed for the processing of personal data. Ethical consideration. AI system for predictive maintenance of network equipment are potential sources of bias. What are the bias? Sampling bias, data imbalance, temporal bias, geographical bias, feature selection bias, human intervention bias, Fairness and social bias, labeling bias. What is this? Sampling bias is the training data used to build the predictive maintenance and model is not representative of the entire network's equipment and the usage pattern. It may lead to a biased prediction. Data imbalance. An imbalance in the distribution of normal and faulty equipment data can lead to biased prediction. Temporal bias. If historical data used for the training is not spread evenly across time, the model may be more accurate in predicting maintenance needs for the older equipment but less effective for the newly introduced equipment. Feature selection bias. Choosing the certain features over others during model development may introduce bias. Some features may have a stronger correlation with certain outcomes. Human intervention bias. Human intervention during the data collection or labeling process can introduce bias based on the labeler assumption or interpretation. Fairness and social bias. Predictive maintenance decision may impact different users groups or regions differently, leading to a potential fairness and social bias concerns. Data labeling bias. The process of labeling data for training purpose may be influenced by human biases. It will affect accuracy and fairness of the model. What is the AI product for? The AI product for predictive maintenance of network equipment meets three goals of ethics. AI. What are those? First, fairness. Second, accountability. Third, transparency. Fairness, the basic detection mitigation, have conducted through data analysis to identify potential bias in the training data and implemented bias mitigation techniques. These techniques will help ensure that the AI model provides fair and equitable prediction across different democratic groups and regions. Fairness metrics. Use fairness metrics to measure and monitor the model's performance across various subgroups, such as age, gender. Accountability. What is accountability? Explainable AI. Adopt an explainable AI approach, ensuring that the AI model prediction are interpretable and understandable. Data provenance and auditing. Maintain a record of data sources and processing steps, enabling transparent data provenance and facilitating auditing to ensure data quality and integrity. User feedback mechanism. Provide users with a feedback mechanism where they can report concerns. Transparency. Model documentation. Data transparency, explanation, policies. Maintain detailed documentation of the AI model, architecture, training process, and hyperparameters and evaluate metrics. Provide users with a clear, transparent information about the data collected, how it used, and the purpose of its processing. Present AI prediction, insights, and recommendation using interactive visualization and clear explanation, making the decision-making process transparent and understandable to the users. Privacy policies and terms of use. Have comprehensive privacy policies and terms of use that outline how the users is handled, stored, how the data is handled, stored, and shared. Thank you very much.